Hi, my name is Tarneja, and you're watching Green Security. We are solving the advent of cyber by TryHackMe, and today is day 17. And the topic for today is CyberChef Hoperation Save McSkidy. Let's get started with the story. McSkidy is imprisoned in King Malhare's quantum variant. Sir BreachBlocker III was put in charge of securing the fortress and implemented several access controls to prevent any escape. His defenses are worthy of his name. However, McSkidy managed to send vital clues to his team using harmless bunny pictures. One message revealed that 5 locks needed to be disabled to secure an escape route. The locks can be broken by examining their logic and leveraging the system's built in chat for the guards. They can be eluded in revealing vital details or even passwords. However, you will need to speak their language. Learning objectives, introduction to encoding, decoding, learn how to use CyberChef, identify useful information in web application through HTTP headers. And let me start the machines and task 2, encoding and decoding. Encoding is a method to transform data to ensure compatibility between different systems. It differs from encryption in purpose and process. Now, what do they mean by ensure compatibility between different systems? Now, computers don't understand our human language, our grammar, right? So, what happens? We use different punctuations, different special characters apart from just simple alphabets, right? For example, if I say hello there, or say at the rate, right? Now, in this particular sentence, we have spaces, we have exclamation, and we have at the rate. Now, if you were to send this particular sentence to a machine over the internet or many other use cases, then it would break down, right? Because it would take it as a separate entity. So, what we do is we take this particular sentence and we try to encode it. Now, if I encode this particular sentence, I get some scrambled text like this. Now, this is easily transferable without breakage. That is why they say here ensure compatibility between different systems, that there can be seamless communication within the systems. Now, when you try to do this encoding and decoding, anyone can decode your data, whatever information is flying around. That is why it is not secure. The aim of encoding decoding is not to secure, but to ensure that things do not break while they are traveling, right? Process standardize and a process algorithm plus key. Encryption is totally different thing. Encryption uses certain mathematical logic and rotations and stuff to ensure that the whatever is traveling across the internet is secured and nobody can read it. It is scrambled in that way and it can only be decrypted with a key. Different logic. Encryption in itself is a in-depth concept. Security, no. Security, yes. Speed, very fast. And encryption is slow. Example, base 64 and encryption is TLS. Now, CyberChef overview is also known as Cyber Swiss Army knife. Ready to cook some recipes? It has operation, recipe, input, output. Like here, operations, what do you want to do? Recipe, in which order you want to carry out different operations, what is your input and what is your output generated based on the recipe and operations. Okay, you can enable, disable, and operation the recipe by toggling the middle button on the right of the operation. Great. Third is inspecting the web pages. That is, in Chrome, we have developer tools. In almost all browser, we just have developer tools. But in Safari, we have develop, show web inspector, like that. So it tells you basic things. This is the dev tool that we are going to take advantage of. We can put it on the right, left, bottom, or in a separate window as per as our convenience. We are logged and loaded, and let us go to first lock. Task 3, first lock outer gate. Key information, if not already, start the machine. We have already. Then what we have to do, McSkidy revealed some vital clues in his message. You will have to leverage any useful piece of information in order to break the locks. First thing is chat is base 64 encoded. Try decoding this with CyberChef. This will be leveraged to extract useful information from the guards. Be aware that from log 3 onwards, the guards will take a longer time to respond. Then we have guard name. This logic will persist throughout the levels. Make sure to note the guard's name for each level. Headers, again inspecting the page but switching to the network tab. This time, make sure to refresh the page once after switching to this tab and select the first response. Login logic, you will inspect the page and switch to the debugger tab, network and response header and logic tab, debugger, and we have the password. Sorry, we have the code. We will inspect the page and switch here. You can also find helpful comments that explain what you need to cook in CyberChef. Okay, so for the entire challenge, we need to look for these four things. First, while interacting with the chatbot Bunnygram, the every time an interaction takes place between Bunnygram and us, what response Bunnygram gives will be encoded. So we have to first decode it, and what response we are to give Bunnygram, it should be encoded. Confusing. And the logic persists, and we have to note down guard name. Then headers, we will go to network tab and look for response headers. And login logic, we will go to debugger and look at the code. So let's try to crack the first log. First, identify the guard name and encode it to base 64. Reach the site, outer gate, outer wall, guardhouse, inner castle, and prison tower. We have to go and get McSkidy. This is the first log, outer gate. This we need to decode. We got the recipe, and if we will paste, and all hail King Malhare. Next, we have to inspect using the dev tools. Gonna say function F12, and I'm going to go to the network tab and refresh. Go to the first request and response headers, and here we have what is the password for this level, X magic question. I'm going to just copy it. I also need to encode, so I will just open another tab and say to base 64, paste, and copy, and what's this first, paste here. We are asking for the question. The question is, what is the password? It should tell us the password. The response from the bunnygram will be encoded, and we will again have to decode it. And what is the username? First, identify the guard name. You will use this at username input. What is the password for this level? That is okay. This is cotton tail. Use the encode magic question. The guard will provide with the encoded level password. Now switch to debugger tab and identify the login logic. In this case, the password is encoded to base 64. By decoding the answer from the guard, you will have the plain text password. Use the encoded username and plain text password to log in. Let us see if this is going to give us the password or the username. It is quite confusing. Let us meanwhile look at the debugger tab, the JS code, user login logic, user okay, A to B user, card name, password logic, level 1 from base 64, B to a password expected constant. Did we get the response? Yes, we did. Cottontail. Let us decode. Here is the password. Is it double encoded or what? I am so fluffy. Now, first log has been cleared. Let us go to second log and oh yes, but what is the username? We got the password, but what is the username in the first place? Um, Hint, this will decode to cottontail. Let us try cottontail. Hmm. This will decode, meaning we have to encode. Again, identify the guard's name and save the encoded output for later. Let us first, this is outer wall, right? Yes. Got carrot helm. We will encode carrot helm. And what is the next drag and encode the magic question again? Same thing, function F12, network tab, refresh. Oops. I have to do that here. Network tab, refresh, link, sorry, first response. And did you change the password? That is also given in the image. Let us encode this. I should, oh, we have already pasted it there, so we can remove this. Did you change the password? Swift response. Again, we have double encoding or not. Look again at the login logic. You see that encoding is applied twice this time. This means that you have to decode base 64 twice. I told you to change it. Alrighty, second stage is here. What is the password? We are gonna paste it. Third log, this will be trend for this and the following levels. As always, collect all the needed information, encoded username, encoded password from the guard, XOR key. Binary operation that XOR. Long ears. Let us first encode this. It should be the username and password will be found by asking the question. So we will do function F12 for here and network, refresh, post request, and recipe key is CyberChef. From this logger, there is no magic question, but sometimes you can ask the guard nicely to give you the password. It will still need to be decoded. Okay, let us try to send base 64. Okay. Please tell me the password. Even a simple password will go a long way. If you look at the login logic, there is a slight twist. The password is first XORed with a key and then encoded to base 64. So we will go to the network tab. Sorry, we will first go to DevTools, go to debugger app and look at the password logic. In the level 3, we have XOR with key and then bytes to base 64. Got the response. The password is first XORed. The password is first XORed with the key and then encoded to base 64. This is the logic for XOR. And okay, but how do I reverse this? Skipping the long math explanation, XOR has a magic property. When you XOR the result with the key again, the new result will be the initial data. Go ahead, try this in CyberChef. Put two XOR operation one after another. Use the same key for both and output should be identical. With this newfound knowledge, build the needed recipe to find the plain text password. Use the credentials and unlock. Alrighty, we have to first see XOR and then from base 64. So over here we will add XOR here and key is CyberChef and our encoded part was this from base 64 and XOR. The path to knowledge is not always straightforward. Consider the shadows. Let us try this exact sentence. Here is the password. Now we will try to use this. It did give us the password, but okay, let us try this with Bugs Bunny. This room has too many riddles. Like there is this, the path is simple but twisted. Not now. Okay, third one down. The password here is Bugs Bunny. Fourth, lock inner castle. And we're almost there in this level. Sir BreachBlocker III throws you a curveball. Let's see how to tackle this. But first, go ahead and look at the login logic as before. We will not be needing header information for this one. Crack station hash lookup. Alrighty, first we will need the username and password. After asking the guard for the password, let's look at the reply. We again need to be polite. Sorry. Says something M5 at the end. And also here we had crack station hash lookup. It is MD5. The password is converted into MD5 hash. Now the hash is not decodable like base 64. So there has to be something else. That MD5 is a cryptographic algorithm that produces a fixed hash value, fixed size hash value. While this is supposed to be one-way function, meaning you cannot reverse it, pre-computed hashes can be leveraged to identify the input. Because MD5 has a very small output, a fixed length small output, common passwords can be easily guessed. So there's no point of hashing it if you can guess it. There's no point of hashing it if you can break into the system. Putting the two together, the plaintext password is passed to MD5 and you have the hash. This looks like a job for crack station. Go ahead and open the site and paste the hash to retrieve the password. I'm gonna go to crack station and it will not load because it is Google. Let us go here then in our native browser, paste it. Paste it here. Interrupt 20 non-salted hashes, one per line. Where, oh, it did let me paste it. Thank you. Oh, wait, I didn't remove this. This is the password. Sorry, my bad. Control C. And password is this. Let us paste it here and bash. Not now. Username will decode to Lenny. We did do that, right? Let us try it again. Something might be wrong with the password. Pass. I will just type it down. Password 1. Must be a typo from my end. Okay, fifth log, present tower, ready for the final hurdle. As the defense is weakened, you receive hidden message. I can see you are ready to break the last log. Be aware that Sir BreachBlocker III implemented different mechanism for the last log, which change occasionally. Make sure you match the correct approach when decoding the password. Let's start. Extract the information as before, noting the encoded guard game. Username to be encoded. Password. First, let us go to the dev tools and check the code for the fifth level. It says R1, R2, rotate 1, 3 from base 64 XOR, and we have 4 cases R1, R2, R3, R4. It is a switch, and we have recipe ID or R1 from base reverse rotate 1, 3. This is the recipe. Let TP is equals to password. Switch recipe case R1, R2, R3, R4. There are 4 cases, and encode card game we went for the username. Additionally, note the recipe ID from the header and match the corresponding login logic. Below is the quick cheat sheet for decoding each recipe. 1, 2, 3, 4. Let's start. Extract the information as before, noting down the encoded guard name. Guard name is found. Password please should be written. Well, let us go step by step. We have something here. What operation is to be carried out is written here. Build a reverse recipe with CyberChef and extract the final password. Finally, the log has been breached. Okay. Additionally, note the recipe. Recipe R3. We have to go to the network. CyberChef. I think XOR will be there. It says R3. Let us check again here. Not here. No DevTools needed here. We go to the network tab, refresh, go to the first request, and here it says R3 and recipe key. R3 and recipe key is CyberChef, means XOR will be there. And what does this say? R3 CyberChef rotate 1 3 from base 64, then XOR. We have to rotate 1 2 3. We have R3. So this is the flow we need to follow. Base 64, then XOR. So over here we need to say rotate 1 2 3. I think this is the password. What is the password? Let us check it. Yes, we cracked the final door as well. What is the retrieved flag? Where is the flag? We need to log in at least. Then we will get the flag. We paste the password here. We go bash, not now, and redirecting flag in 2 seconds. And there we go. And done. McSkidy passed by the inner castle. She heard a thunderous voice. Why should Christmas have all the fun? McSkidy managed to get back to the Wayville just in time as TBFC was about to be hit by another disaster. And that's it. Check, check, and we're done.